Okay, in this section, we'll talk about deep learning. Okay, deep learning technique. Okay, deep learning is one of the most hottest technique in computer science and engineering. Okay, in recent years. Okay, I think many people, okay, without the machine learning background, know the deep learning technique through the Go game, the very famous Go game, okay, between AlphaGo, okay, and top human player from Korea, Lee Sedol. Okay, actually, the underlying technique, okay, of AlphaGo is deep learning model. Okay, the basic uh, algorithms, okay, used in AlphaGo, okay, is deep learning model. It's deep learning model. Actually, I'm a amateur Go player many years ago. I mean, many years ago. Okay, so before this match, I don't think AlphaGo can win. Okay, because our Go game is a very complicated game. I mean, very complicated. It is estimated that the possible situation of a Go game is equivalent to the number of atoms in galaxy. Okay, very complicated. The number of possible situations of a Go game is equivalent to the total number of atoms in galaxy. Okay, very complicated. However, okay, AlphaGo won the game. And what shocked me more is that during these games, okay, AlphaGo made some moves that the human beings will never ever took. Okay, such as the move 10 and move 12 in the first figure, and the move 37 in the second figure. Okay, the move 10, move 12 in the first figure, and move 37 in the second figure. Traditionally, we think these moves are bad moves. Okay, but after the game, the top human players, carefully studied okay these moves and found that okay, well we still cannot see these moves are a good or bad, okay, good or bad, but these moves really have some advantages compared with traditional moves. So this means that the deep learning models can not only learn human knowledge, but also can create new knowledge based on existing knowledge. Okay, can create new knowledge based on existing knowledge. It is a very amazing characteristic, right? So we really hope such a characteristic of deep learning models, okay, can be used in medicine and healthcare applications, okay, particularly in medical image processing, okay, applications. Okay, actually the AlphaGo software is developed by DeepMind. Okay, it is a sub company of Google. Okay, working on AI technology. DeepMind is a sub company of Google. And after the AlphaGo, the DeepMind further developed Master and AlphaZero, two advanced Go game software. Currently, okay, the top human player almost have no chance to win the AI-based Go software. Okay, so the AI-based Go programs have dominated the Go game. Okay, that also demonstrated how powerful the deep learning techniques are. Okay, actually, okay, in principle, the deep learning technique is a kind of representation learning technique. Actually, in the early stage of artificial intelligence AI technique, most AI models are knowledge-based artificial intelligence models. That is, the model is designed based on the prior knowledge of human beings. But the performance of these simple machine learning algorithms depends heavily on the representation of the data. Okay, if you have a good representation of the data, okay, probably the model can perform very well in this task. But if you cannot represent the data well, okay, in many cases, okay, the knowledge-based artificial intelligence may fail in such a task. Many simple artificial intelligence tasks can be solved by designing the right set of features to extract for that task. However, for some complicated tasks such as image analysis, image processing, or analysis, quite difficult to design the features, to design representation. Okay, so in such a case, okay, a research direction called representation learning is proposed. Okay, representation learning work on not only mapping from the representation to output, but also the representation itself. Okay, it means that the representation learning, okay, cannot only learn how to use representation to achieve good results, but also, okay, work on learn how to achieve representations, how to get a good representations for the data. Okay, actually, in principle, deep learning is a kind of representation learning. Okay, deep learning, okay, learn representation by introducing representations that are expressed in terms of simpler representations. Okay, you can see from the following slides that the deep learning model actually is a hierarchical neural networks. Okay, in the neural networks, we first learn some simpler representations, and based on the simpler representations, we form relatively complicated representations to represent the relatively complex data. Okay, so in principle, remember that the deep learning is a kind of representation learning technique. While deep learning models has been studied for a long time, okay, the first breakthrough, okay, of using deep learning models in practical applications, okay, is published in 2012. Okay, in NIPS that year. NIPS is a very famous conference, academic conference on artificial intelligence and machine learning. In 2012 NIPS, okay, the researchers published a paper entitled ImageNet Classification with Deep Convolutional Neural Networks. Okay, so what is ImageNet? ImageNet is an image database organized according to the WordNet hierarchy, in which each node of the hierarchy is depicted, okay, by hundreds and thousands of images. Okay, so it is a very large database containing a large number of images. So the classification task is that in the image net, okay, there are large number of classes of the images. For example, the images, okay, containing houses, persons, pets, okay, or other classes, okay, or trees, okay, other classes. The classification task is to classify these images into different categories, such as house images, car images, person images, or pet images. Okay, to automatically given an image, the algorithm can automatically classify this image into the correct category. Okay, this is a classification task on ImageNet. Before this paper is published, okay, the error rate, okay, the error rate of this classification task on ImageNet is 60.9%. Okay, that means among 100 images, around 60 images are wrongly classified, okay, into different categories. Okay, the error rate is very large, right? This paper, reduce the error rate to 40.9%. Okay, it is a very huge improvement, right? Okay, improve the classification performance by around 20%. So, okay, because of this huge improvement, okay, the deep learning models, okay, draw more and more attention from both academia and industry. Okay, so do you know, okay, the recent results of this classification task? Actually, in 2015, okay, in the 3 or 4 years, okay, the researchers further, based on deep learning models, further reduce the error rate to around 5%. That means from 100 images, only 5 images are wrongly classified. Okay, so it's very, okay, huge improvement of this task. Okay, it's also demonstrated what a powerful technique deep learning models are. Okay, so very powerful technique. Actually, among many different deep learning models proposed in recent years, the most commonly used or widely used is convolutional neural networks. Compared with traditional artificial neural networks, convolutional neural networks are inspired by animal visual cortex, okay, in which the individual neurons are organized in a hierarchical way. Okay, actually, many years ago, the scientists have discovered that the animal visual cortex contains complex arrangements of cells and observe things in a hierarchical manner. Okay, for example, in this image, okay, the animal or human visual cortex first observes some primitive features such as the edges, corners, and then, okay, combine these edges, corners, and these primitive features into parts of the objects such as the bark, the leaves, and finally, they combine these parts of the objects into the tree in this image, right? Recognize the tree in this image. So the animal human visual cortex recognize, okay, an image in a hierarchical way. Okay, the convolutional neural networks actually try to simulate, okay, this mechanism of the animal or human visual cortex. Okay, try to, okay, analyze an image in a hierarchical way. Okay, this is a typical architecture of CNN convolutional neural networks. Okay, it is composed of a stack of layers, okay, in a hierarchical way, okay, as mentioned. Usually, there are 3 kinds of layers, okay, involving in a CNN architecture, convolutional neural networks. Okay, the first kind of layers is convolutional layer. Okay, it is a core and a basic block in a CNN, because as you know, the network, the neural network is called convolutional neural network, right? So the convolutional layer, the convolutional block is the basic and the core layer, okay, of the convolutional neural network. The second kind of layer is a pooling layer. The reason for pooling operation is that, okay, we want to merge the small similar features into one relatively larger features. Okay, so that we can greatly reduce the parameters and convolutional cost in the convolutional neural networks, and hence can overcome the famous overfitting problem. Okay, so remember that the pooling layer is used to reduce the parameters, reduce the computational cost, and and avoid the overfitting problem. And finally, after a set of convolutional layers, pooling layers, convolutional layers, and pooling layers, after a set of convolutional layers and pooling layers, finally, the main purpose of the network, okay, the high-level task, the high-level semantic task, such as detection, segmentation, and classification, can be done by a fully connected layer. Okay, so in summary, there are three kinds of layers: convolutional layer, pooling layer, and fully connected layer. The convolutional layer, okay, is used to extract features, particularly small features, okay, at the bottom of the CNN. And then we use pooling layer to merge, okay, the small features, small similar features into relatively larger features. And then based on these features, okay, finally we use the fully connected layer, okay, to perform the detection, segmentation, and classification task, finally, okay. So three kinds of layer, remember this. As mentioned, okay, the convolutional neural network is kind of supervised learning methods. Supervised learning methods, okay. As mentioned, in a supervised learning methods, okay, there are two stages: training and testing. Training and testing. So in such a case, first we should collect a large number of labeled data to train the convolutional neural networks. Okay, imagine that we want to classify an image into different categories, such as house, cars, persons, pets. Okay, a lot of categories. We should first collect a large number of these images, okay, with different categories, okay, and all these images are labeled, okay, by humans. So we use this labeled, okay, images, okay, to train the convolutional neural network. Okay, in recent years, okay, considering the labeling is a very laborious and time-consuming work. Okay, some techniques has been developed to automatically or semi-automatically generate the labels for images. Okay. Anyway, we should collect a large number of labeled data to train the convolutional neural network. During the training, okay, give an image, and the network produce an output in the form of a vector of scores. Okay, so we hope the desired category has the highest score. For example, we input a car image. Okay, so we hope the class car, category car, has the highest score. Okay, on the other hand, other categories such as person, train, pet, house, okay, and plane has relatively low score. Okay, the car has the highest score. To achieve this, we should calculate an objective function to measure the errors between the scores and the ground truths. Okay, so during the training procedure, we should modify its internal adjustable parameters, also called weights, to reduce the errors, okay, between the scores and the ground truths. Okay, then we should compute the gradient vector, okay, which is used to indicate by what amount of error would increase or decrease if the weight were increased by a tiny amount, So in such a case, we use a technique called stochastic gradient descent, okay, to calculate, okay, by what amount of error would increase or decrease if the weight were increased by a tiny amount. In such a case, we can adjust the weights, the parameters, to minimize the objective function and reduce errors, so that we input an image, okay, we can get satisfactory results, okay, based on the model. Okay, so here is an example of the convolutional neural networks. Okay, so we input a car image, okay, and go through convolutional layer, pooling layer, convolutional layer, pooling layer, convolutional layer, pooling layer, and finally fully connected layer. We can have a vector of scores of this image. Okay, you can see that after training, the car category has the highest score, so that we can classify this image into car category. Other categories, truck, airplane, ship, or horse, has relatively low score. Okay, so in such a case, okay, we can classify this image based on the highest score. We can classify this image into car category after a lot of training. Okay, so these figures show the basic principles of the workflow of convolutional neural networks. So in next section, we will talk about how to use convolutional neural networks to perform medical image segmentation tasks.